going to be doing is looking at a specific question that involves regions. And I'll be giving you step-by-step instructions on how to do it, okay? And so let's have a look at this one, which says graph the region y is greater than x plus 2 and y is less than or equal to 3 minus x. So let's start off with step 1, graph the line / boundary. Now for the first example, it's y is equal to x plus 2, and for the second example it's y is equal to 3 minus x. Okay, so what you will find is that x plus 2 has a gradient of 1 and a y-intercept of 2. So let's put that 2 there and the gradient of 1, which is over here. And then this one here, y is equal to 3 minus x. It's got a y-intercept of 3 and a gradient of minus 1. So it'll be this line there. Got it? Okay. Now the next thing that we need to do is to determine the boundary nature. And what I mean is whether it's broken or unbroken. Okay. So for this example, see how it's greater than 2 and not greater than or equal to 2? So this is going to be a broken line. Whereas this equation, and I've changed it to make it more interesting, y is less than or equal to 3 minus x, that's going to be an unbroken line, okay, because it includes the boundary. Step 3 is determine region by substitution. So by substitution, what I mean is, for this line here, the region's going to either be the bottom half or the top half, right? And the way you work out whether it's the bottom half or the top half is by substituting, and a good point to substitute is always the origin, 0, 0. So let's put in 0, 0 and see what happens. 0 is greater than 0 plus 2. 0 plus 2 is 2. So is 0 greater than 2? No. So it's not going to include the region that has the origin in it. So it's going to include the other region, okay, the other side. And so I'll show that by putting little arrows to indicate that that's the region that I'm concerned with. Got it? Alright. Then we'll do the same thing with this one. Let's substitute 0 in. 0 is less than 3 minus 0. What's 3 minus 0? The answer is 3. So is 0 less than 3? The answer is yes. So it will, for this line, include the region that has the origin in it. So it'll be this line here, or this region here. Okay, so the first step was graph the line or the boundary. The second was determine the boundary's nature, whether it's broken or unbroken. And the third one is determine the region by substitution, or the regions by substitution. And then step 4, consider if union or intersection, and or, whether it's the overlap or the combined portion. In this situation, we're using the word and, so it'll only include this part of our answer. So, the answer will be this part here. Okay, so it's the overlap between this region and that region there. Okay, so the other thing that I wanted to mention about this is that this line here, the remainder of this line, the unbroken line, is not part of our overlap, is it? Alright, so this line, or this part of that line, the part that's not overlapping, will need to be an unbroken line. Oh, sorry, a broken line instead of an unbroken line. Whereas the part that is included in our overlap will remain unbroken. Okay, so the 4 steps, let me reiterate. Step 1, graph the line or the boundary. And that'll give you the boundary. Step 2, determine whether the boundary is broken or unbroken. Alright, the third step is which side of the boundary is the region going to be on, and you determine that by substitution. And then the last part is to consider whether it's an overlap or whether it's a combined region. So that concludes, this is the last episode of linear functions. Thank you very much for watching.